Title of tonight's DNA discussion is Visual Triangulation, and I'm going to introduce some concepts that may be new to you here. I've talked about triangulation in the past, and we're going to talk about a specific method of triangulation to deal with some of the obstacles that generally challenge us on a day-to-day basis if we are working on genetic genealogy regularly. This is my usual full disclosure statement. You can read that at your leisure. And as usual, I'll ask you to hit the like button, share this material with people who have similar interests, leave comments, subscribe to my YouTube channel. This is a Facebook live presentation. Those of you watching it live know that, of course. But this will be posted on YouTube later so that people can watch it there, and the recorded video will also be available on Facebook. So this is a live presentation that is being recorded for viewing later. If you need to find my YouTube channel, you can click on the link on this slide. And I'm working to make sure that these presentations are very interactive. So I'll try to remember to stop at points and check for questions. We'll certainly have time for questions at the end. So ask your questions as they come up, and I'll address them when I can. So there are quite a few screenshots in this presentation. I just want to let you know that these are real screenshots. They've been modified a little for privacy and for clarity, but these are real examples of real matches. And I'll have some details in this presentation. I don't expect you to keep up with all of the details. The details are just there to reinforce the big picture. If you are interested in the fine details, you can view the video later and review all of the details that you're interested in. So just a quick description of visual triangulation. Visual triangulation is a process where we make indirect DNA comparisons, and so by making indirect DNA comparisons, we're able to compare DNA matches at one DNA testing company with DNA matches from another DNA testing company. So we can overcome an obstacle there and amplify the power of our DNA match results by crossing those barriers. And visual triangulation, being indirect, also allows us to compare DNA matches with each other even when the chromosome browser settings do not permit that. So I'm thinking specifically of family tree DNA with that statement. Family tree DNA has a good chromosome browser, but that chromosome browser does not allow you to compare your matches with each other. So visual triangulation is a way to overcome that. I'll be right back. So visual triangulation has a lot of power to help us with things that can be very challenging otherwise, and ultimately gives us the power to make comparisons and allows us to sort matches in ways that would not be possible without this method. So just to back up a little bit, for those of you who may not be deep into triangulation, I'll tell you what triangulation is. This could be just a refresher, short refresher for some of you. So triangulation is simply a process of looking at shared DNA matches and shared ancestry to explore family relationships. And this term triangulation has gotten broader over the years, but during this presentation we're going to talk about triangulation in terms of looking at shared DNA segments. There are other ways of thinking about triangulation, but with visual triangulation we're talking about looking at shared DNA segments to explore shared ancestry. And the process of triangulating starts with selecting a shared segment of DNA. So you might be looking at a DNA match that you're particularly interested in for some reason, and you may share more than one segment, but you'll start typically with the largest segment because that usually tells you the most interesting story, and you look for other people who share that segment with the two of you, and then after that you look for ancestry shared by all of the people who share that segment. So you may find a small or moderate-sized group of people who share a relatively large segment, and you'll look for an ancestral line that might be able to account for the DNA that all of you share. And then you can repeat that process segment by segment for each of your matches, and you can get a lot of insights, very precise insights into your family history through this process. So that's the general concept of segment triangulation. And we're going to focus on a specific method of triangulation. But before we move on to that, I'm going to give you an example, a simple example of triangulation. And this is an example that comes from my Spivey cousins, and those are maternal cousins. So here you see a chromosome browser comparison from 23andMe where I'm being compared with 4 cousins, and all of us share DNA on a specific portion of chromosome 1. So we all share DNA there as confirmed by multiple comparisons, and you can see a visual representation here. And over time we were able to explore our family trees well enough to determine that the source of that shared DNA on chromosome 1 was Edmund Spivey. So Edmund Spivey is the recent common ancestor who accounts for our shared DNA. And that's the basic concept behind triangulation. And if you want to get deeper into the details of the general concepts of DNA triangulation, you can follow this link to my video where I discussed DNA triangulation more generally. And when we talk about triangulation, we're really talking about 2 parallel challenges. One challenge is to confirm that the mutually shared DNA, or the apparent mutually shared DNA, is actually shared by everyone in the triangulation group. So when we talk about a triangulation group, we're talking about a group of people who share a specific segment of DNA on a specific chromosome in a specific location, and we have to make sure that everyone does share that segment. We want to be sure that it's not just apparent, but that the shared DNA is actually shared. And the parallel challenge is to confirm the shared ancestry, as we alluded to with the previous example. With visual triangulation, we're focused on that first challenge. And you may be wondering, if you're new to triangulation, why all this fuss about confirming mutually shared DNA? If it looks like you share DNA on chromosome 1, doesn't that settle the question? Well, appearances can be deceiving, so you really do need to take an extra step or two to confirm that the shared DNA truly is shared by everyone in the group. And here's a little bit of the science behind that problem. Our entire genome is represented with DNA from both parents. So every location across every chromosome in the entire genome has DNA from both parents. You have 2 copies of every single chromosome. 1 copy is from your mother and 1 copy is from your father. So at any given location on any chromosome, you can have matches from your mother and you can have matches from your father. And so your matches at any given point along the genome really break down in 2 groups, maternal and paternal. So again, focusing on chromosome 1, as we did with the previous example in the Spivey cousins, they might all match up here, but we have to confirm that they're from the same half of my family tree. So in the case of the Spivey cousins, they're all maternal matches, and we have to confirm that one way or the other. Another match could come along and be in the same location, but be from the paternal side. So we have to develop methods and strategies for sorting that out. And this exemplifies that problem. Here's a match from family tree DNA. The Spivey cousins that I mentioned earlier were all on 23andMe, and we were able to compare them with each other one by one to confirm that they all match each other. But this match from family tree DNA, although the DNA shared is on chromosome 1 in the same location, we have to be very careful not to incorrectly assume that this gentleman, Mr. Adams here, family tree DNA, matches the Spivey cousins. It's very tempting to conclude that this DNA is the same DNA shared by the Spivey cousins at 23andMe because it's on the same chromosome and the same location. And Mr. Adams does have some Spiveys in his family tree, but we need to be careful not to jump to conclusions prematurely. We need to look at that very carefully. But unfortunately, we have a barrier between family tree DNA and 23andMe, so we can't do the direct comparisons that we would like to do, and we have to find another way to ensure that what we think we're seeing is what we're actually seeing. So we have to answer the question as to whether this segment came from my maternal side or from my paternal side, and we'll talk about those strategies going forward. So to answer questions like this, to sort out issues along these lines, we can sort our matches, we can compare our matches, and we can confirm the connections with various strategies. One of the easiest ways to sort matches is to test parents, test grandparents, test great-grandparents if you have great-grandparents that you can test, and you can even test other relatives. Some of your other relatives will offer opportunities for sorting out matches. But I'll note that even if you do have the good fortune of being able to test your parents and your grandparents, the oldest generation is always going to present you with a sorting problem. So, for example, if I had known about genetic genealogy early enough, I could have tested 3 of my 4 grandparents, and that would have helped me greatly with sorting out my matches, but then I would still be faced with the challenge of sorting out their matches. So a match to my grandfather would immediately raise the question as to whether it came from his paternal Smith line or his maternal Arnold line. So testing family members does help a great deal, particularly if you can test parents and grandparents. But even if you manage to do this, you're going to be faced with the issue of trying to sort out their matches, and so you want to take advantage of every tool you have at your disposal. And here are some of the tools that you can use to sort things out. Chromosome browsers are very helpful. Those are available at 23andMe, GEDmatch, MyHeritage, and Family Tree DNA. There are various triangulation features that you can take advantage of. You can find those at GEDmatch, 23andMe, MyHeritage. And visual triangulation is a tool or method that you can use with any of your matches from any of the DNA testing or matching companies that provide a chromosome browser or matching segment information. And we'll get into that as we go forward. That's the whole point of tonight's discussion. So I would emphasize that you do want to make direct comparisons when you can make direct comparisons. You want to make direct comparisons with chromosome browsers and triangulation tools when you have access and when there are no barriers that prevent that. But that's not always going to be possible. So for example, a direct comparison between cousin A, who's only tested at Family Tree DNA and doesn't have results anywhere else, and cousin B, who's only on 23andMe, is not possible. You have a barrier that prevents the direct comparison that you would prefer to make. And so here's a real example of this problem. So the real example of this problem comes from my cousin Graham Bennett. That is a pseudonym. He was a new match to me in the early part of early part of 2017, and of course he was one of my top matches. That's why I'm talking about him, and I was interested in how we're related, but he has no tree. I sent him messages, I got no response, but fortunately, because his name is somewhat unique, it's more unique than the pseudonym that I provided, and the spelling is a little bit unique, and because Family Tree DNA encourages users to provide their email address, I used his name and his email address to find his mother's obituary and some other helpful information, and I was ultimately able to build his family tree for myself. And in that process, I found that we were related through two different common ancestral couples. We were related through Alexander Dean and Sarah Williams on one of my maternal lines, and I found that we are related through John Barber Waters and Martha Lanier on one of my father's lines. And so the paternal relationship is a fourth cousin's once removed relationship, and the maternal relationship is a second cousin's twice removed relationship. So the maternal relationship is a good bit closer, and it's fairly safe to assume that most, if not all, of the DNA that we share came from that maternal relationship, but we cannot make that assumption with absolute certainty. We do want to explore this possibility as well as we can to get the most accurate picture possible from the shared DNA. So this illustrates the closer relationship, the second cousin's twice removed relationship. This is Graham, this is my family, and these are our closest shared ancestors. So looking at the DNA that Graham shares with my family, it comes to a total of 104 centimorgans, which fits nicely with my mother's second cousin once removed relationship with Graham. So we have a good amount of DNA to work with, and that generates some questions. Can we possibly confirm Graham's tree with the DNA match results? Remember, I built his tree on my own, didn't get any confirmation from Graham. I'd like to do as much as I can to confirm that tree with the DNA match results that we have. Another question, very closely related question, can we confirm the source of the shared DNA? Can we confirm that the DNA actually came from the Dean line? And can we explore the possibility of some of that DNA having come from the paternal line? And of course, since this is a visual phasing, a visual triangulation discussion, we're going to be asking whether triangulation can help us with these questions. So again, Graham tested family tree DNA, and we believe that we're related on the Dean line, and I do have a good number of other Dean cousins, but unfortunately it seems that all of my good DNA matches are at 23andMe. So we have this big barrier between Graham and the rest of my Dean cousins, and we have to figure out a way to deal with this barrier. So we have a great match, we share some great connections, but the direct comparisons that we would like to make are just not possible because of the fact that they're in different databases. So I offer a solution for cases like this, and the solution I offer is visual triangulation, which gives us the opportunity to make indirect but very reliable comparisons, I believe. And the goal in this case is to compare a family tree DNA match with some 23andMe matches. So what do we need to do visual triangulation? We can't simply do one-to-one comparisons. We need other family members. I would argue that it's very helpful to have representatives from at least 2 generations of your family. I think those kinds of combos are particularly helpful. And of course, we need matching segment details. Triangulation is all about segments, particularly with visual triangulation and traditional triangulation as we understand it. So we have all of those resources. Family Tree DNA has a chromosome browser, so we can get some detailed information about the DNA that Graham shares with my family, which totals approximately 104 centimorgans, spread across 4 chromosomes, chromosome 3, chromosome 6, chromosome 10, and chromosome 21. And I'll note that in this case I have access to match results for 12 of my close family members, including me, and that will help us considerably. You don't necessarily need anywhere near that number of family members to do visual triangulation, but that's what I have, and so I'm going to take full advantage of my resources, and that will work us through this example. So the family members available in this case: me, several of my siblings, sibling 2, 4, 5, 6, 7, 8, 3 children, and a nephew and a niece. And as I mentioned, I have some good Dean matches at 23andMe, and when Graham showed up on my match list at Family Tree DNA, I thought about some of those matches and remembered that they might be helpful in this case. So I went back to 23andMe and I found Millie. Millie is another match that I had to work hard on. I didn't get Millie's information handed to me on a silver platter, but she did have some good information on her 23andMe profile, and that allowed me to build her family tree. And again, when Graham appeared, I compared notes, and I found that Graham and Millie are uncle and niece. So a very good match to explore, but we have this barrier. Graham is on Family Tree DNA, Millie is on 23andMe, and so we have a challenge in front of us. So we went ahead with the information that we did have, and I found that Graham matches my siblings on chromosome 3. He matches siblings 4, 6, 7, 8, and niece B. Niece B is 4's daughter. So that is according to Family Tree DNA, and this shared segment is on position approximating 29 million to 41 million, and I found that Graham's niece also matches siblings 4, 6, 7, 8, and niece B in the same location on the same chromosome. So I'll go ahead and tell you that when we see a pattern like this, an identical pattern, despite the fact that they've tested with different companies, we see an identical pattern on an identical location on the same chromosome, we can begin to assume that these two people match each other in that location. We can begin to think about the fact that they probably, in all likelihood, do match each other in this location. Moving on, we find that Graham matches me and sibling 4, sibling 7, sibling 8, and all 3 of my kids, according to Family Tree DNA, in this position on chromosome 3. So a little further down the chromosome, between 61 million and 71 million approximately, Graham matches this subset of my family. We also find, according to 23andMe, that Millie matches the exact same subset of family members in this location, roughly between 61 million and 71 million. So on the basis of this very specific pattern, I would conclude that Millie and Graham more than likely match each other on this segment. Moving on, another important match at 23andMe is Karolina. Again, when Graham popped up, I started looking at my Dean matches at 23andMe, and I compared notes, and I found that Graham and Karolina appear to share a nephew-aunt relationship. I know Karolina's family tree to be accurate. Karolina's daughter responded to some of my messages, and so I know that she is Ira Dean's daughter, and I know that these connections are correct. So this is a more certain connection, and if my tree for Graham is correct, then he is Karolina's nephew. So let's look at the DNA match results for these two people. Graham matches siblings 2, 4, 5, 7, and nephew E, according to Family Tree DNA, in this part of chromosome 3. So from approximately 175 million to 183 million, this is where Graham matches this specific subset of family members in my family. Then I look at Graham's aunt, Karolina, and I find that she matches the exact same subset of my family in the same location on chromosome 3. So again, as previously noted, when we see this identical pattern in the same location, we can reasonably hypothesize that these two people match each other. Likewise, on chromosome 6, we have a subset of family members who match Graham and a subset of family members who match Karolina. This is the same subset, and the matching is occurring in the same location. So on and on we go, chromosome after chromosome, we're finding Graham and Karolina matching the exact same subset of my family members in the same locations on the same chromosomes. So again, that tells me not only do Graham and Karolina match each other in these locations, given the fairly large number of segments where they're showing up again and again together with the exact same subset of my family members, I'm starting to get to be more confident that Graham and Karolina are closely related to each other. This is the kind of pattern that you'll see when you find two matches. You don't necessarily know that they're closely related to each other, but you see them coming up together over and over and over across your family's genomes, and that should lead you to suspect that those people are closely related to each other. And then finally, on chromosome 21, yet another segment where Graham and Karolina both match an identical subset of my family members in the same location on the same chromosome. So we can summarize the observations that we've made up to this point, and we can build some hypotheses on these observations. So, so far we've seen that Graham at Family Tree DNA and Millie at 23andMe both match identical subsets of my close family members on two segments on chromosome 3. So on the basis of that observation, we might hypothesize that Graham and Millie match each other on chromosome 3, and that we can hypothesize further that Graham and Millie triangulate with my family on those segments, and they triangulate on those segments because of the shared gene ancestry. Furthermore, we've made the observation that Graham at Family Tree DNA and Karolina at 23andMe match identical subsets of my close family members on several DNA segments, specifically on chromosome 3, chromosome 6, chromosome 10, and chromosome 21. So we can hypothesize that Graham and Karolina match each other on chromosome 3, on chromosome 6, on chromosome 10, and on chromosome 21. We can hypothesize that Graham and Karolina triangulate with my family on those segments, and we can hypothesize that Graham and Karolina triangulate with my family on those chromosomes because of the shared gene ancestry. So those are our hypotheses, and this brings it all together. So we have this family tree showing the connections: Millie, Karolina, Graham, my family, but of course we still have this barrier that prevents direct comparisons. However, I think with what we've seen so far, we can be safe in assuming that Karolina and Graham are related as shown here, Millie and Graham are related as shown here, and the DNA that we share on the various chromosomes that we've discussed is DNA that we all inherited from this ancestral couple. Now, if you have seen some of my previous presentations, you know that I like to cheat a little bit with these, and I have the opportunity to cheat here because last month Graham finally appeared as a match to my family at 23andMe. He never responded. I'm not sure what he's up to, but I'm glad that he showed up on 23andMe for whatever reason. We usually don't get this lucky, but we've gotten lucky in this case, and so now we have the opportunity to see if the hypotheses that we came up with as a result of the visual triangulation that we did is actually correct, or if those hypotheses are actually correct. So, picture of Ira and Ruth Dean here, our ancestors, just to make this interesting. Here's the family tree now, and we can now put 23andMe under everyone, or with everyone here, because we're all on 23andMe and we can begin to make direct comparisons. So what do we see when we make the direct comparisons that we could have only hoped to make when Graham first appeared? Well, here in purple on the left we have Graham versus Karolina, and this shows that they share more than 2,000 centimorgans, and that fits reasonably well with a nephew-aunt relationship. And here on the right in the orange we see that Graham and Millie share nearly 1,800 centimorgans. That again fits with an uncle-niece relationship. So things are looking good with this information. We can dig a little deeper and we can see that Graham and Millie share quite a few segments, and in particular we're interested in chromosome 3. As we discussed earlier, Graham and Millie match me and my family on 2 segments on chromosome 3, and this large segment that they share here in the middle on chromosome 3 is roughly from the position at 31 million to the position at 113 million, and that spans both of the segments that Millie and Graham both share with my family. So as predicted by visual triangulation, we see that Graham and Millie do indeed match each other on chromosome 3. Furthermore, if we compare Graham and Karolina, we can see that as predicted by visual phasing, they do match each other roughly in the position that we predicted that they would match each other on the basis of the DNA that they share with my family. Going further, we see the same thing, roughly the same thing on chromosome 6. Visual triangulation predicted that Graham and Karolina would share DNA with each other where they share DNA with my family, and that is exactly what we see with the direct comparison with the chromosome browser at 23andMe. And then on chromosome 10, we see the pattern repeat. Again, we see Graham and Karolina sharing DNA where visual triangulation predicted that they would share DNA. And finally, on chromosome 21, again, the predictions that we came up with as a result of our visual phasing, as a result of our visual triangulation comparisons, it looks good here too. So just to add another layer of evidence to help us with our hypotheses here, we can utilize the triangulation tool at 23andMe, and we get to the triangulation feature by pulling up the shared matches list. They call this relatives in common. So my sister here and Graham have a list of shared matches, and Millie, Graham's niece Millie, is on their list of shared matches. So this shows up nicely, and Millie is showing up as Graham's niece. And in this column here that says shared DNA, we have a yes. That yes means that they triangulate with my sister, sibling 4 here. So if we click on the yes, we're taken to a page and we're shown where they triangulate. And here with this purple and orange stack, this other purple and orange stack, we see that Graham and Millie triangulate with my sister on both of these segments as predicted by visual triangulation. So triangulation confirmed, traditional triangulation confirmed the visual triangulation in this case. Moving on to another person on my sister and Graham's list of shared matches, we find Karolina, Graham's aunt, and they also have DNA that triangulates with my sister. So we click on the yes, and that takes us to the next page where we see that Graham and Karolina do indeed triangulate with my sister here on this third segment on chromosome 3 that we talked about earlier. So again, another layer of evidence of triangulation in this location, emphatically confirmed with the triangulation tool at 23andMe. Finally, we can go to the shared match list that I have for Graham, and Karolina is on the list of matches that we share. We both match Karolina. Karolina is Graham's aunt. There is a yes here to indicate that there's some triangulation going on, and if we click that yes, we're taken to the page that shows that Graham and Karolina triangulate with me on chromosome 6, and Graham and Karolina triangulate with my family on chromosome 10, or triangulate with me specifically on chromosome 10. So once again, triangulation is emphatically confirmed with the triangulation feature at 23andMe as predicted by visual triangulation earlier before we had access to this set of tools. For reasons I don't have time to discuss right now, we're not able to access the triangulation tool for chromosome 21, but that's a relatively small segment, and so it's no big loss. But in conclusion, in reference to the case of Graham Bennett, visual triangulation correctly predicted segments that Graham shares with Millie and Karolina, and visual triangulation correctly predicted triangulated segments that ended up being confirmed by direct comparisons. And I've seen this over and over and over. I don't expect you to take my word for this. I'd ask you to take a look at this process for yourself and see how well things line up. Another point in discussing this case, we don't want to lose sight of total centimorgan values. We did come to that when we got Graham's match results at 23andMe, and we showed that the total centimorgan values shared by Graham with Karolina and Millie were as we would have expected. Let's just remember that total centimorgan values predict the distance of relationships, and that's very helpful information to combine with triangulation information when we have the opportunity to do that. So to summarize that previous slide, I would say the amount of DNA shared, total centimorgans, gives you an idea of how high up the tree you need to climb to find the common ancestors, whereas the location of the shared segments tells you which branch you need to climb to get to those shared ancestors. So to visualize that, centimorgan values might have us focusing primarily on this generation, and information about individual shared segments on individual chromosomes might have us focus on this specific line. And when we compare total centimorgan values with segment information and individual chromosome information, we can really focus in very nicely in many cases. Another point of discussion, visual triangulation can be done with fewer family members. I mentioned that earlier. You don't have to have 12 close family members to do visual triangulation. You can get by with far less. As I mentioned earlier, parent-child duos are particularly powerful, and if that's all you have, you're still in pretty good shape. But if you do have more family members to test, if you do have access to match results for a larger number of close family members, be sure to take advantage of that, because with more family members you do get a more complete picture. I would also emphasize that visual triangulation can be done with other groupings of family members. It doesn't have to be like the group of family members that I used in this specific example. It could be quite a different group, and you can begin to see how there's some flexibility there just by shifting the perspective in this example that we've already discussed. So from my perspective, this was self and siblings and children and a niece and a nephew, all compared with Graham and his close family members. But if my daughter had done this same study, it would have been self, father, aunts, uncles, siblings, and first cousins. So it's just a matter of perspective, and you can see if Graham had done this exact same study, for him it would have been self, aunt, and niece in comparison with a bunch of distant Lee matches. So just to shift the perspective on this specific example, you can see that depending on how you approach the problem, you can solve the problem with very different arrays of family members. And in fact, I would say that if you don't seem to have the family members that you think you need to do visual triangulation, just flip the perspective. And what I mean by that, say for example, you've only tested yourself and you don't have access to DNA match results for parents or your children or siblings or any close family members. If you're trying to sort things out with a match who has tested his or her parents or children or siblings, then you can do the visual triangulation from their perspective, and that will work just as well. And this strategy is particularly accessible at 23andMe and GEDmatch, where the chromosome browsers are especially flexible. So if you're new to all of this, that point might be not quite as obvious, but I did feel the need to emphasize this point because it does open up a lot of opportunities that some people would not otherwise have. So one final point in the discussion, I'm going to emphasize what I've emphasized before. Direct comparisons are still preferable to indirect comparisons, so we want to continue to urge people to use all of the databases, take advantage of GEDmatch, MyHeritage DNA, Family Tree DNA. We want to make direct comparisons as much as we can, but we do have to confront the fact that many, if not most, of our matches are only going to show up in one database, and if we're lucky, that one database will have a chromosome browser, and we're going to have to find a way to compare matches in one database with matches in another database with a good number of matches who are never going to cross over that barrier to show up in multiple databases. So visual triangulation is the answer to, or at least one very useful solution to that persistent problem. So I'll also note again, visual triangulation helps to deal with chromosome browsers that don't allow you to compare your matches with each other. I'm thinking particularly for Family Tree DNA. They have a good chromosome browser over there, but you're not allowed to compare your matches with each other, so visual triangulation can help out there, particularly given the fact that Family Tree DNA also has no triangulation tools. So visual triangulation is really going to play a big role with your matches at Family Tree DNA if you're working as hard as possible to put those matches into context. And this basically summarizes the fact that visual triangulation comparisons really open up a huge number of doors. I put dashes here just to emphasize the fact that you don't really need to do visual triangulation with 23andMe to 23andMe comparisons because their chromosome browser is very flexible. You could do it if you wanted to for some reason, but I really can't think of any good reason to do that. Likewise with GEDmatch. These kinds of comparisons are completely impossible at Ancestry. So if you have great Ancestry matches that you'd like to work with in this way, you absolutely have to get those matches, persuade those matches to download a copy of the raw data file so that they can upload it to GEDmatch or Family Tree DNA or MyHeritage DNA, where matching segment information, chromosome browsers are available. And then very last point here, I've done so many visual phasing comparisons, visual triangulation comparisons. I probably said visual phasing a lot of times when I meant visual triangulation, but I mean visual triangulation. So I've done so many visual triangulation comparisons through the years. I started out being fairly hesitant about drawing conclusions on the basis of visual triangulation because I still prefer to do the direct comparisons when possible. But over time I've begun to see that I can't really think of any times when visual triangulation didn't work out as expected. So rather than asking you to just take my word for it, I spent a few hours looking at some pairs of matches at 23andMe, a little over 250 pairs of matches, and I chose those pairs of matches at random from several chromosomes, and I found matches that share at least 10 centimorgans with me and 10 centimorgans with my child, and I found that all 252 pairs of these matches ended up matching each other as expected, as predicted by visual triangulation. So I'd be interested in seeing if anyone comes up with anything radically different, but from my experience and from my little study here, I have concluded that visual triangulation is extremely reliable and a very powerful way to reach conclusions that we would not be able to reach any other way, and to leap across barriers between the DNA testing companies, barriers between the DNA databases, to make comparisons that would otherwise be impossible. So again, I don't want you to take my word for any of this. I'd like you to try visual triangulation for yourself. Maybe you're already doing this process. Maybe there are a lot of people out there already doing this. Maybe they have another term for it. So I'd like you to try visual triangulation for yourself. Tell me what you found if you've already been doing it. Tell me if you've seen any problems, if you've seen any cases in which visual triangulation doesn't work for you. Just let me know what you think. I'm very interested in this because I haven't really seen any presentations or blog posts about this specifically. So I'm interested in what other people think. So again, if you got something good out of this video, hit the like button, share it with people who would be interested, leave your comments and questions, follow the link to subscribe to my YouTube channel. And again, if I said visual phasing during this presentation several times, I really meant visual triangulation. So sorry about that. And at this point, I can address any questions that have come up. So as Lewis Kessler had a question earlier, I'm not sure when he asked it, but his question was, I've heard the term segment triangulation and I've heard the term visual phasing, but I've never heard the term visual triangulation. Where did your term come from? Well, basically I made that up. I'll admit that I just made that up, and I got the idea to call it visual triangulation because in a sense, if you're familiar with visual phasing, it's almost a localized visual phasing with the purpose of triangulating. So I thought it was a pretty good term. If somebody else has a term that's already in use for this process, then I'll certainly defer to what is already out there, but I haven't really been able to find any kind of discussion about this exact process. So I made up the term and I'm open to other ideas. Absolutely. So let's see, what else do we have? Lynn says, huge thanks, Jason. I never would have imagined this was possible. So I'm glad that you like that, and I hope that you end up being able to use that and to solve problems with it. And I'm certainly interested in what people find in their own research. So again, we're talking about visual triangulation. I think a few times I might have said visual phasing, which is a completely different process. If I said the word visual phasing at any point during this presentation, what I really meant was visual triangulation. Sharon says, no family members left here previous generations. So you don't have to have previous generations of family members to do this. You can utilize match results for siblings, for children, for other family members. And as I mentioned at one point, you can even, take advantage of the fact that some of your matches have tested their parents, they've tested their children, they've tested their siblings, and so you can approach the visual triangulation questions from their angle, and it works just as well. There's a link to my YouTube channel. You can find that here. Lewis Kessler said, I've attended plenty of online genealogy presentations, but I think this is my first ever Facebook Live session. Looking forward to it. Hope that you got a lot out of this. I think it's a good way to do DNA discussions online. Dory asks if we can access a recording later. As soon as this presentation is over, just a few seconds later, it will show up as a recorded video on Facebook, exactly where you watched it initially. And I will be uploading it to my YouTube channel, so you can find it there as well. It will be available in recorded form, both here on Facebook and on YouTube. Lewis Kessler, very good session. Thank you, Lewis. I appreciate that. I know you do a lot of work, and you've put out some good material on your blog, so I appreciate that. You say, Jim Bartlett's fantastic segmentology.org site is all about the triangulation work he has done over the past 5 years. Jim also wrote the chapter, quote, Lessons Learned from Triangulating a Genome, unquote, in the new Advanced Genetic Genealogy book edited by Debbie Wayne Parker. I saw that, and I do follow Jim's blog. He is doing excellent, amazing work, and his blog is essential for anybody who is deeply into triangulation. He's definitely an authority on triangulation, and I'd be interested in knowing what he thinks about visual triangulation. I think he'd probably be open to it. I should put words in his mouth, but based on what I've seen in his writing, I think he'd at least be interested. So, supposedly we've got 30 people watching at this point. I'm certainly willing to answer any other questions. I hope I didn't confuse anybody by mixing up the term visual phasing with visual triangulation. Tonight's topic was visual triangulation. And I think this would be a good video to transcribe. Actually, YouTube does closed captioning, and you can copy the closed captioning, and I'll probably just do that and edit that to work well for a blog post, an extended blog post. So if you'd rather read than watch a video, I'm pretty sure I'm going to go ahead and convert this to a blog post as soon as I can, using the transcription that YouTube will ultimately produce automatically for us. Alright, again, this video will be available as a recorded video both on Facebook and YouTube, so you can ask your questions there, either one of those places, and I'll be happy to answer. I'm definitely interested in hearing about any problems or questions or doubts about this, but I've done it quite a bit and it works great for me. So with that, I'll close things up, and I certainly appreciate your time and attention, and I look forward to talking to you again soon.